Hi, I'm Aaron from Living Science Videos. Throughout this series, we'll be asking questions and examining what science knows about living things. But how do scientists know anything? How can we know if they got it right? It's simple. Just think like a scientist and follow the evidence. But there are some rules. Science is both a body of knowledge that represents our current understanding of natural systems, and it is also the process to refine, elaborate, revise, and extend this knowledge. Think of it as an investigation. So the most important thing you can do is to ask questions, but these must be testable questions, because we have to be able to tell which answers might be right from which ones are definitely wrong. Here are two questions. You evaluate which one is scientifically testable. Pause and write down your answer explaining how you could test that based on what is already known. 1. Are diseases caused by pathogens, or what are more commonly called germs? 2. Is your friend telling the truth when they say there's a dragon living in the garage? Now, you might think that there's an easy answer to the dragon question, especially since no one has ever shown any evidence that anything like this has ever existed. So what are the chances of finding one in the garage? Why haven't you seen it before? Where's it been hiding all this time? But it would be really cool to see a dragon, right? So, of course, the first thing you do is look in the garage, surprised at the number of dragons you don't see there. Where is it? Why can't I see it? Now, what if your friend doesn't play fair when you ask these things and just makes up excuses for the lack of evidence rather than giving you any reason to believe it? The dragon is invisible. Right. Now, you know how light is reflected to show color, and this is already ridiculous, but like a good scientist, you propose a hypothesis. You know that if there was an invisible dragon there, that its body temperature, its movement, and the motion of the air as it breathes could all be detected somehow. So you suggest using an infrared motion sensor. But your friend says that won't work because it's cold-blooded, holds still for a long time, and exists in another dimension so that you can't hear, smell, or touch it either. There's absolutely no way to test for it, and no way to show whether they're right or wrong or just making it up. As absurd as that is, it is logically impossible to prove a negative, so you could never prove that there's not an imperceptible extra-dimensional mythical monster in your garage. It's up to your friend to prove that there is one. The burden of proof is on the one making the positive claim, and you have to allow them that. So you ask the question you should have asked in the first place: how do you know there's a dragon there? I know because I know. I just know, that's all. And nothing you could ever do or say will ever change their mind. This problem with the dragon in the garage was proposed in an essay by the famous scientist Carl Sagan. If you think like a scientist, then you'd have to conclude that there's probably not any dragons in the garage or anywhere else. But you have to be ready to change your mind if given good reason to. That's because science is tentative, meaning that it can change if new evidence is presented. But science can only work with what is measurable. If it can never be demonstrated by any means at all, ever, and it can never be disproved either, then it is an empty claim of no interest or value to science. Now let's look at the second question. Are diseases caused by germs? This is an easy one because we live in modern times where pathogens were already proven to exist by earlier scientists. Thanks to education and literacy, we have the advantage of more accumulated knowledge than at any prior point in history. In earlier times and all through the ages, people had some weird, creepy, and scary ideas about what caused diseases. They thought that people got sick because of evil spirits, or because of an imbalance of bodily humors. Maybe they had bad blood, or too much blood. Yeah. So doctors of the day would put live leeches on you thinking that would help. Now that seems laughable now. But back then, if somebody's cow got sick, the villagers would blame it on witchcraft and somebody might get burned at the stake over that. As long as people don't know what's really happening, they'll still blame it on magic. It wasn't until the 1860s that the famous biologist Louis Pasteur put all these superstitious explanations to rest. He disproved the ruling explanation of the day that disease was caused by miasma, or bad air. People would actually complain that they had the vapors and fan themselves or faint because they thought they were breathing in bad air. And there's some truth to that, because before there was deodorant, toothpaste, soap, sewers, or sanitation, people lived in some stinky, infectious places. Pasteur researched early attempts to combat diseases through vaccination using a weaker form of a pathogen to train the body's immune system to fight the disease. People had repeatedly observed that if a person once had a disease called cowpox, they wouldn't later come down with the more deadly disease of smallpox. And this prompted a hypothesis. If cowpox is a weaker, less deadly germ but related to smallpox, then a person vaccinated with the cowpox virus should develop an immunity to smallpox too. An earlier test by Edward Jenner in 1796 using the cowpox virus yielded promising results. Pasteur applied the same hypothesis to another disease. He figured out how to weaken the germ that caused anthrax. So he performed an experiment as a public demonstration in 1851. He vaccinated 30 animals and had a control group of 30 more that were not vaccinated. A couple weeks later, he injected them all with full-strength anthrax bacteria. Within a few days, all the unvaccinated animals were dead or dying, but all of the vaccinated animals were alive and healthy. It doesn't get much more conclusive than that, and Pasteur patented the first anthrax vaccine. In 1885, he further improved public confidence of vaccination by saving the life of a 9-year-old boy infected with rabies. Pasteur was not a licensed physician, so he could have gone to jail if he'd injected the boy and it didn't work. But back then, you didn't survive rabies. The vaccine was the child's only hope, and it did work. Louis Pasteur was a national hero who advanced medicine, saving millions of future children's lives by developing vaccines and proving that diseases weren't caused by evil spirits or bad air, they were caused by germs. The reason vaccines work is because they're based on facts and laws known about diseases and how they work. A law in science is different than what people normally call laws. The laws of nature are observations of fact which can be expressed as either a sentence or a mathematical equation, like Einstein's famous equation E equals mc squared. Likewise, a theory in science is different than a lot of people think too. A theory is not the same thing as a guess. It has to be testable and falsifiable. If, after rigorous testing, the scientific community validates a hypothesis, it will graduate to the level of theory, and that's as good as it gets. Theories don't become laws. They are higher than laws and include laws. A scientific theory is a substantial explanation of some aspect of the natural world based on a body of facts that has been repeatedly confirmed through observation and experiment. Pasteur's experiments have withstood the test of time and have been used by other scientists to form the germ theory of disease. This doesn't mean that germs are only a theory. It means that germ theory is the only scientifically tested and verified explanation of transmittable diseases and the body's immune responses to them. So the next time you have to get shots, thank scientists like Louis Pasteur, because sure, you have to get a shot. But if you've ever seen some of these full-on diseases, you'd rather just get the shot. I know because I know. I just know, that's all.